graphs of functions. And I think sometimes it's good to have a visual again. So I mentioned that pop machine. I actually had my husband record a video of it so you can kind of see what we're talking about when we're talking about a functioning pop or soda machine. So he went to his work with a highly subsidized soda. It's $1/4 a can. A little shaky. He's holding his phone trying to do this. So $1/4 went in, 1 input, and 1 output. As far as the soda machine is concerned, everything's functioning properly. If you $1/4 went in and nothing came out, they don't care. They're still making money. When is it not functioning? When $1/4 goes in and 2 sodas come out. So here's a function box. We have the function f of x equals 2x minus 3, and I'm placing x equals 2 into that function box. What should come out? 1, right? Because when we place 2 in for x, 1 comes out. So we'll try another number. Let's put 4 in. When 4 goes in, what's going to come out? 5 makes sense. 1 input, 1 output, everything's good. We flip it around. Now f of x is the square root of x, and I'm putting 4 in. So when 4 goes in, what's coming out? 2. So out comes 2, because f of 4 is 2. There's a problem. Negative 2 is also coming out. Why? The negative number squared is a positive. Okay. Likewise, we put in 25. What should come out? 5 and negative 5. So now it's not functioning properly because 1 thing went in, 2 things came out. That's a relation, not a function. Okay? So we can represent relations in a number of ways. We can give them to you in tabular form. We can give them to you in a list of ordered pairs and set notation. We can do mappings and so on. Let's look at this first example. Our input column is 2, 3, 3, and 4, and our output column, the y's, are 17, 14, 11, and 11. Is it a function or not a function? Okay, everybody agree. I hear people say no. Agree or disagree? Why is it not a function? Yes, Ray. Good. 3 has 2 different outputs. 3 went in, 1/4 went in, and a Diet Mountain Dew and a Pepsi came out. Okay, so there's a problem. How about the second relation? Is that a function or not a function? Hearing yes. Agree or disagree? Agree. Anybody disagree with that one? Okay, so -3 to 4 is a 1-to-1. 7 to 4 is a 1-to-1. Does it matter that we put in 2 different quarters and got out Coke each time? Perfectly fine, right? Likewise, when we put in this quarter or this quarter, only 1 came out. That's just 1 flavor of soda that's coming out. So for each input, we had exactly 1 output. All right, we can also ask you then, if we give you a graph, a graphical view of a relation, we can ask you whether that's a function or not. So what do you think for part C? I'm seeing some nodding, I'm seeing some shaking heads. So disagree, agree, we don't have a consensus here. So how are we going to figure that out? Let's pick one of our inputs. What's an easy input? What's an x value that we want to look at? -2. Okay, so here, when x is -2, what's y? 0. So we put -2 in and 0 came out. That's okay, right? Okay. What's another value for x? 0, okay? Here x is 0. What's y? Hard to tell. That's 1, so 1 point something, right? But what's this? Negative 1 point something, okay? We had one value of x, 0, but we have two values of y. 1/4 went in, what happened? Two different sodas came out, okay? So is this a function? No. And when you're looking at a graph, we have something called a vertical line test. Which means that if at any point on the graph you can draw a vertical line and that vertical line touches the graph in two different places, one value of x has two different y's, two different outputs, it's not a function. Make sense? Okay, so these are easier probably than these are because you don't really have to think about it. Just think vertical line, am I going to hit it in two places? Okay. This is a function that you will be, or a relation that you will be looking at later on in the, I think, second semester. What do you think about this one? It is a function. Does everybody agree? Does anybody disagree? Okay. Why do you think it's a function? Vertical line test. Doesn't matter where I go with my vertical line. Am I ever going to find a place where I can hit it in two spots? Nope. So that is a function. Okay. Last example, example E. What do you think? Function or not a function? Not a function. Why? Doesn't pass the vertical line test, right? And that can be your justification, your rationalization for that. Anytime you're given a graph and you can show a place where it does not pass the vertical line test, that's your rationalization for it. Okay? Everybody remember this stuff? Or at least comfortable with it if you don't remember it from the past. Okay, so next example. Now we need to talk about the domain and range for our function. So this is something you discussed in Algebra 2. You may have talked about it in Algebra 1. Not likely you ever saw it in geometry. What are we wanting when we ask you for the domain of a function? All the real numbers is what we typically will say, right? All real numbers such that, such and such, okay? But what are we talking about from domain versus range? What does domain stand for? The x's, the inputs, okay? And the ranges, the y, the outputs, okay? So may be helpful when you're looking at these to do some shading. So when I want to know the domain, okay, and this is a kind of a funky function, or a funky, well, it's a function, right? Passes the vertical line test. This is kind of different because it's got something weird going on here. It doesn't go on forever, right? It does a turn and another turn, and then we've got a big old point here, okay? What's the difference between this and this? Open circle versus closed, what's the difference? Inequality, right? Yep, good. So closed circle is equal to, it can become this point, but it cannot quite reach that one. Is everybody comfortable with that? Okay, that's the distinction between it. And you will see, when we get to rational functions, places where there's a hole in the graph. There's a gap. And when we pull out our graphing calculators, when we trace that, we will actually find those holes and gaps. Okay, there'll be good reasons for that. So we can be the point 4, -2, but we cannot be the point -2, 4. Okay, so here's what we're talking about then when we're talking about domain. Domain is all of our inputs. So you ask yourself, okay, I'm starting out here. What's the smallest value of x that I can be? -2, almost, right? But we can't quite be -2. And I can keep going, I can go, and I can go. I have x values here, and x values here, and x values here. And where do I have to stop shading for the x's? At 4, right? Because this function's only defined between -2 and 4. Okay? So the way you were likely taught to write your domain is all real numbers such that x is between -2 and 4. And x is smaller than the 4 but bigger than the -2. So we want the alligator's mouth, Ms. Pac-Man, whoever, opening to the x, right, in the first case, and less than the 4, maybe with your left hand, on the second side. Where does my equal to symbol go? First or second inequality? Second, why? Because it can be that point. You see that closed circle? Okay, so that's my domain. Now that's how we have typically written that in the past. But in Algebra 2, we also talked about the interval notation for this. So how would we write this as an interval notation? Does anybody remember? -2, comma 4. And then what did I put around the outsides? Open parentheses on the left side because it can't become -2. And what goes on the right side? A square bracket. So rounded bracket or parentheses on the left, square bracket on the right. Okay. I know you've been exposed to this. I don't know that you've mastered this. So if this is a little new, jot it down. Open parentheses means less than or greater than, right? It means it can't touch it, can't be that number. Close parentheses means it can be that number. There's an equal to, there's a closed dot, there's an open circle here. Okay. Now let's talk about the range. So if we shade along our y-axis now, we're talking about the values that we can have for y. What's the smallest number that y can be? -2. Can it be -2? Yes, because of that closed circle. So we can start, the lowest it can go is -2, and then we can work our way up, and we have a function. We still have a function, actually a couple different place values for x where we have y at those positions, and now we still have a function, and then what happens when we get to 4? It can't be there, right? Gets infinitely close, 3.99999999999, right? But it can't become 4 because of that open circle. So the open parentheses means that you can't be that number. Okay, it's because of that open circle, the non-filled in dot. So what's our range? And write it both ways so that you're familiar with it. All real numbers such that we're going from what to what? -2 to 4 again, right? Okay, I should have done a better job with picking something that was more elongated or what have you. So -2 less than, but not equal to, what goes here? Y less than equal to 4. Or if we were writing in an interval notation, now we say we cannot be -2 but come infinitely close to it, but we can become 4, still close bracket by the 4. Okay. What questions do you have on domain and range? Are we good? Mm-hmm. I'm sorry. Yes, thank you. Thank you. You caught me. Made a mistake. -2 we can be, can't we? We have a closed circle here. So we need our equal to here. And we need our brackets to change. Apologies. So negative 2 less than equal to y and plain old less than 4. Good catch. And so therefore, we can be negative 2. We want a square bracket here. And we want a open parentheses on the 4 side. Speak up sooner. Saw the perplexing look on your face. Need to say something. I make mistakes. Everybody does. All right, everybody good? Questions you have on domain and range? All right, next thing. Now we're asked to find, and this is just notation. It's not hard math. It's just getting used to our book and how it's what it's asking for. So we're asked to find f of negative 1. So if this is our function, f of x, what do you think they want you to do if they want you to find f of negative 1? What did you do this weekend when you were given a algebraic expression and asked to find f of negative 1? Remember? If my equation was f of x equals 4x minus 3, and I asked you to find f of negative 1, you did what? Plugged it in, right? Everywhere we see x, we put in negative 1, right? Okay. So this is a slightly different appearance because now we're not given the equation, are we? But we're asked to look at the graph and decide what is f of negative 1. So negative 1 stands for x, and we're asked to find out what's y at negative 1. Okay. So we go here where x is negative 1. And where x is negative 1, we have nothing down below, but it looks like we have a point right here. So what's the value of y when x is negative 1? 1, positive 1. Okay. F of 0, 0. What's the value of y when x is 0? How about f of 2? Yeah. And finally, f of 3? Good, because over here when x is 3, the function is 1. Make sense? Okay, visual verification. Your graphs on your book will be kind of tiny, so we're looking for a range. Okay. All right. Or not really a range, but I'll accept answers that make logical sense. Okay, so now the next question is, how do we find the zeros of a function? What do you think they mean by zeros? You said it equal to 0. We want to know where is the function equal to 0 at? Very nice. Okay. How do we solve something like that? Good. We're factoring to figure out what multiplies to become 3 and subtracts to become 2. So what goes in your first parentheses? X and x, that's x squared. And what are the two numbers we're using? 3 and 1. And we're subtracting to become 2. We want it to be a positive 2, so plus 3 and minus 1. So we factored it. Now how do we solve that? How do we find those values for x? Yep, set each parentheses equal to 0. If x plus 3 is 0, what's x? Good. And if x minus 1 is 0, what is x? Positive 1. So if we looked at the graph of this guy, we would see a parabola, which is what we should expect. We've done enough parabolas in our day in Algebra 2 with an x squared. Opening up, we didn't know what the vertex form was, right? But we can see that it has zeros at negative 3 and positive 1. Okay. Those are the two places where it crosses the x-axis. Those are the values where y is 0. What questions do you have on this slide? Okay. So far, so good? All right. Next one. G of x is, what does this little 3 mean? That's the root number of the index, so cube root or third root, right, of x minus 2.2. So we want to find the zeros again. What does that mean we do? Set it equal to 0. If 0 equals the cube root of x minus 2.2, what do I have to do to solve that? Cube it. Yeah, opposite of cube root is cube. So if I take this to the third power, taking the other side to the third power, what's 0 cubed? So radical disappears. What's x going to be? 2.2. If we look at the graph of this guy, we didn't do a lot of graphing of cube roots, but that makes sense, right? Something cubed goes like so, and this is the place where it crosses the x-axis, where y is 0. Ringing a bell? Making sense? Okay. Last example of these. Find the zeros of this guy. While we're at it, let's find the domain of this one as well. So when we're finding a domain of a function and they didn't give us a graph of it, we have to figure out what are the possible values that x can be. What do you think? What are the two things that we cannot do in real number system? Awesome. The base cannot be 0. The denominator of our fraction can never be 0 because we can never divide by 0. So x cannot be equal to -2 because that causes a problem. The other thing that we can't do in the real number system, anyone remember? We can divide by negative, but we can't take square roots of negatives. Okay? Can't take square roots, fourth roots, sixth roots, eighth roots, even roots of negative numbers, right? In the real number system. We can call them imaginary. You were introduced to those last year. But we can't take square roots of negatives or cube root, fourth roots of negatives. Okay? So this is our one concern. Okay? So old way of writing it, all real numbers such that x is not equal to -2. Okay? What would that look like in interval notation? We can't be -2, right? What's the smallest number it can be? Can go -1. How about 0? -5, -2,000, -50 million. Can those all work? How far can we go? Forever, right? How do we write that? -infinity. So we never reach infinity. That's why we use a open parentheses with infinity. And we can't be -2. We can go up to positive infinity, though, can't we? So this is the way to exclude -2 from our domain. Open parentheses, -infinity, comma, -2, close parentheses, or same open, not a square bracket, regular parentheses. Okay. All right, so what are we going to do to find the zeros of this guy? What does it mean to find the zeros? What did we do back here? So yeah, set it equal to 0. So we say 0 is equal to 3x squared minus 2x minus 8 over x plus 2. That's like a 0 over 1, right? How do we solve a fraction equals a fraction? Yeah, cross multiply. 0 times x plus 2 is gone, and I get 3x squared minus 2x minus 8. Now what do I do with that? We factor, exactly. And this is a little more difficult because it has a leading coefficient of 3, but not impossible. So what are factors of 3x squared? 3x and x, yep. Now we have to think about factors of 8 that in some combination are going to eventually